Okay, so now we have example 6, all right? Capital rationing dependent projects. Now, what if we now have other requirements that to invest in project C, we must also invest in project D, right? So that means you've got to invest in two different types of projects together. So to allow for such constraints, we use a subtraction method. So what's a subtraction method? Well, let's learn and find out. So what we do is that we map out all possible outcomes when accepting the two projects. So we use 1 and 0 to mark acceptance or rejection. We subtract the bin values of one project from the bins of the second and observe the result to see the values that indicate acceptable outcomes. Okay, so now if you look at the below, okay, what we're seeing is that the first two options are not possible because they don't meet our constraint where we've got to invest in project C and D. Okay, you must either do both projects or neither. So we need the result to be 0 when we actually take the difference in the bins, like 0 minus 0 is 0 and 1 minus 1 is 0. Okay, so that's how we actually use the subtraction method. Let's take a look. So now what we do, we use solver as before, but we need to make sure that we check that it has met our dependent project constraints. Okay, so what we do now, we actually proceed with adding some new functions into our spreadsheet. So we have the funds invested, okay, where that's going to be same as before, equals sum product of all this stuff multiplied by all this stuff. Okay, that's it. And this one is our invest, and this is a binary function, equals the sum product of NPV and all this good stuff here. Okay, so what we actually do next, we have to have our subtraction method. Okay, what do we mean by this? Okay, so let's look at what we had before. Okay, so we just have it, okay, to invest in C must invest in D and vice versa. Okay, so project C, so 0 1 1 0 1 0 1 0, and we will actually go no, no, yes, yes. Okay, and what we do over here is that we have subtraction of this, C22. Let's see, sorry. All right, just moving around. Okay, so what we have is we have the subtraction method, right? And just keeping everything consistent for all of you at D24, 25, 23, and D23, okay? So what happens is that we need to make sure that result here has to be a 0, okay? So what happens is that our requirement is that okay, so what we're doing over here is that we need to see that project C minus project D equals 0, right? And then what happens is that this is just going to be 0 here. So what we're saying over here is that, like, we actually set up these constraints, okay? So what we're going to do next is that we're going to use a solver. Okay, what are we doing over here? So now what we've done, we set the objective, which is C16, to the maximum possible value by changing E5 to E12, which is our invest column. We said that B18 has to be 0. Okay? And B18 is basically project C bin minus project D bin. And the other two constants remain the same, whereby if we actually look at C14, funds invested, it has to be less or equals to 1 million. And what puts E5 to E12 must be binary numbers, and we click on solve. Okay, so let's see what has happened here. Okay. Oops, where did that go? Oh, Jesus. Okay, so it's correct. That's correct. Okay, that's taking those two. So basically what we actually did was that this subtraction amount over here actually comes from this table. That's why we set that to 0. Okay? Because we're saying that, okay, the conditions in which it must meet is that the outcome of project C and D must be 0, then it complies with the requirement. We could change this to 1 and -1 too. Okay, so let's just solve it. Okay, so now it tells us in order to have this in order to actually get the outcome, that you must do both projects or neither. All right, this is basically what the outcome looks like. Okay, so basically we can see over here it's 1 0 1 1 0 1 1. So use the same solver before, but we need to check that we have met our dependent project constraint, which is based on this subtraction 0, which is from this table. Okay, so now if we look at part example 7, how about if it's on capital rationing for contingent projects? So what if we discover to invest in project, we must also invest in project F, assuming that you can only invest in project F alone. So E is contingent, so its acceptance only depends on the acceptance of F, right? So we also use the subtraction method. So what happens is that we create another scenario here, okay, whereby we have the same details as before, okay, whereby this is going to be, let's create some product, let's create some product. I'm going to change all of that to delete all of that over here, okay, and we're going to put in that table, okay, to invest in E must invest in F, but can invest in F alone. Project E 0 1 1 0, okay. Project F 1 0 1 0. Possible, yes, no, yes, yes. Outcome -1 1 0 0. So what this table is actually doing, it actually helps us understand what conditions, okay, we're actually looking for, right? They're actually acceptable. So these are the acceptable ones, right? Where it's actually in green, okay? So we can tell it right now that our subtraction, okay, can allow us to actually have so this table over here is mentioned, it allows us to actually understand what outcomes from the subtraction method will actually make it possible, right? So what we see over here, only when the outcome is a 1, that's not acceptable. So anytime the subtraction value is less than 0, it's acceptable, right? Because it's less than or equal to 0, it's 0 or it's -1, okay? So basically, less than or equal to 0, we have found an acceptable answer. So what we do over here, we actually look at, let's take at E minus F. Just like what we did here. This was actually basically E minus F, right? It was going to be and this one is just one put that as no fill. Okay, so we have the same thing over here, but we just have to adjust our solver, right? So our solver, we're just going to make sure that B18 is now less than or equal to 0, which is basically what we have here, or less than or equal to 0, which is the constraint we have here. So we continue to maximize NPV. C16 NPV is maximized, changing variable cells E5 to E12 with these constraints where E5 to E12 are binary. C14 must be less than or equals to C2, okay, which means that the funds invested must be less than $1 million. And now the constraint that B18, the subtraction formula, must be less than or equal to 0 to allow for this capital condition, rationing condition project constraint to be addressed. So we solve it, and it gives us these three. Okay, so that's it, right? So all we changed, as mentioned before, in solver was B18 less than or equals to 0. Okay, so now let's look at example 8. Okay, so now what we actually do over here is that, however, is capital ration for mutually exclusive projects. What if we now discover that between projects A, C, and E, we can only choose to invest in one of them? So now to allow for this constraint, we use the addition method. Okay, so what happens if we actually look at it right now? We actually look at what the table is going to look like. So the table in this case is going to look like, let's say A, C, and E, possible outcome. Okay, now we have 1, 1, 1, 1, 1, 0, 1, 0, 1, 1, 0, 0. And what we're just doing is just looking at all possible scenarios, right? And then we're actually listing what's possible and what's not. Okay, so we know this is no, 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 yes, no, yes, yes, yes. Okay, so we're going to take out that equals to plus to addition, plus all of them. So we want the conditions where these things are true. So we see over here, okay, that we want conditions where it can be 1 or 0, right? It can be 1 or 0, okay? So basically we want to say that it can be 1 or less than 1, right? So basically we're going to say that equals to A plus C plus E. Okay, and we're going to say that based on what we have in the outcome has to be less than 1, right? So let's look at the solver. We see that B18 is less than or equals to 1, right? Which is what we talked about here. So when we click on solve, it gives us the combinations, right? That allow us to actually achieve the outcome. So in short, this is how we've actually showed how to use solver to actually work out different types of solutions for project investment. So I hope you've all enjoyed the lecture. Please try to actually work on these things yourselves, okay, without looking at the solutions. And the whole idea is to get used to all the different functionality in Excel for capital budgeting purposes. Please look at your quizzes as well, and we will see you in the next set of videos for class number 2 tutorial.